So, hi everyone, my name is Kavya Vuribindi. Today we are here to present our paper titled Real-Time Suspicious Activity Detection on ATMs using Multimodel YOLO Object Detection Algorithm. So here, first we'll see the problem statements that we are trying to solve here, and then we'll go through the related work, and then see what our proposed solution is to this problem. We'll then discuss on the architecture that we used, the data that we collected, and the models that we built with their respective results. There's a short demo video as well at the end, so please stay tuned for that. And we'll then discuss the paper that we wrote and the future scope of this project. And finally, we conclude it. So there are around 3.2 million ATMs worldwide with $400,000 cash withdrawals happening every second. So this accounts to about 17% of world's GDP. Most of the individuals who utilize ATMs often encounter the issue of card skimming and card trapping, which can lead to significant financial losses. So there were around $1 billion losses per annum due to card skimming in 2021, and there were 161,000 compromised cards in 2022 alone. So these numbers are huge. So when I say card skimming and card trapping, these two attacks are basically done by devices called card skimmers and card trappers. So card skimmer is basically a device that is installed on top of the regular card reader on the ATM. So when it is installed, this card skimmer transmits the sensitive information on the card wirelessly to the criminal. And card trapper, on the other hand, traps the card into it so that the user cannot take it back. So this is how a basic skimming attack happens. So the criminal first goes to an ATM. He then installs a card skimmer or a trapper onto the card reader of the ATM. So unaware of this, a user goes to that ATM and puts his or her card onto the card reader, which is actually a card skimmer. So this card skimmer now transmits the sensitive information on the user's card, such as the card number, CVV, and expiry date, etc., to the criminal wirelessly. And the criminal then makes a counterfeit card out of this data and uses it for his own transactions. So, this is how people are losing a lot of money these days because of these skimming attacks. So in spite of having a dedicated surveillance team or a security guard and CCTV cameras, these attacks have become unavoidable. So when we came up with this problem, when we have researched on this problem, we saw a few papers that presented a few solutions, but all of them were not related to card skimming and trapping attacks. So for example, there's photo based ATM security, which actually provides access to the ATM, like provides access to the ATM only to the authorized users. Like all the when a user goes to the ATM and uses it, the image of that particular person is taken and is matched with the image of the authorized user that is stored in the database. So if there's a mismatch between these two images, then an alert is sent to the authorized user. So this is a very good approach, but this doesn't address the card skimming and trapping vulnerabilities. So there's biometric ATM access control as well, wherein fingerprints and eye retina are scanned. But this also doesn't mitigate the issue of card skimming and card trapping. And there's smart ATM security as well, which checks for a face when a user tries to use the ATM. So if a face is not detected, warnings and passcodes are generated for security purpose. So all these papers also do not address the card skimming and trapping concerns. So we have come up with an AI-powered solution using YOLO V5 algorithm to detect suspicious activities involving card skimmers, card trappers, face masks, and weapons like iron rods and hammers. So all this is done in order to prevent users from falling victim to criminal activities. So this is how our solution works. Our model takes inputs from the cameras that are present or that are installed onto the ATM. Like this 1, 2, and 3 are the cameras. The live footage from these cameras is fed to our model. Our model then generates output logs, and these logs are displayed onto the screen of the surveillance team. The surveillance team can then take necessary action just by merely clicking a button. So for this purpose, we have given 5 powerful action buttons for the surveillance team to respond immediately. So there's inform bank button, which actually sends an email to the respective bank with the suspicious activity details. There's turn off ATM button that would turn the ATM off so that no additional damage can be done to the ATM. There's lock door button, which locks the door of the ATM room so that the criminal gets trapped inside the ATM room. And there's police button, which calls the nearest cops and gives them the details of the suspicious activities. And there's ignore button as well. So whenever the surveillance team monitors the logs, they can see the live footage of the ATM machine when a log is created here by clicking these cam 0, cam 1 and cam 2 buttons. So if at all the surveillance team feels that this particular record is a false positive, which is a very rare case. So if at all it is a false positive case, then ignore button is clicked and this log gets vanished from the list. So this is how all the buttons work. And this is the architecture that we used. So here's the user. The user tries to invoke the web server. The web server consists of our full stack application, and here's our MySQL database that is connected to the web server. The models that we built will be running on a separate server on cloud. So the live footage from CCTV cameras will be fed as input to our models, and then our models run and generate logs and sends them to the MySQL database. The web server will always be looking for new logs from the database, and if it all finds new logs here, it will display them to the user. So this is how the architecture is. And this is the tech stack that we used. We used Ultralytics YOLO v5 model and trained various models with our own data. We used Python for programming the entire code. We used OpenCV extensively for the data collection, and Flask for our backend framework. And we hosted our application on AWS. So the rest of the presentation will be continued by Akshith.
Thanks for Kavya for your explanations. So here's the data collection for our models. So this is the trained data set, and this trained data set consists of like 11,000 images. Each class has like 1,000 images, and then like combination of images, and there's like neutral images which is used to maintain the low false positive rate. So in neutral images we use per cell phone, face without mask, COVID mask, ATM card, and few background images too. So this is the test data. So test data is separate from the training data to figure out the accuracy and the false positive rate and all those stuff. So we took like 200 images, equal images to find the precise accuracy for each class. So this is the baseline model, which is our first experiment with all the data set we like collected. So here we use the entire data set 11,000 images to train a single model which is capable of detecting all the classes or all the objects, and we used like around 100 epochs here. So it consists of the complete data set, and the baseline model results are shown here. So we got like R schema around 61%, and the remaining percentages are shown here. So with this, we did not receive a good reasonable accuracy in the previous experiment, so we went for multi-model approach. Here, what we took, the approach we did was we separated each class with single model. So there is no a single model which is capable of detecting all the classes. So each class has its own model, and we use like 500 epochs here. And to train each model, we used 1,000 images of the object and 200 neutral images, so that to maintain the low false positive rate. And we also eliminated the combination of objects while training these models. And the results of the multimodal approach is here. where we got a very good reasonable amount of accuracy, like 92% for card skimmer. And in the next experiment, we are planning to improve the remaining models. So this is the multi-model improvement. So here what we are doing is we are training the card trapper with just 500 images alone, and we removed even the neutral images too. So here we are using 500 epochs to do this, and we got like a better accuracy. And for face mask detection, we took like a separate approach, like a unique approach to say. And here we used two pre-trained YOLO detection models to detect a person and a face. So we use a separate business logic to do this. Like for example, if a person is detected and face is not detected, then it means that face mask is bad. If person is detected and face is detected, then the face mask is not van. So this approach is used here, and the result of this approach was pretty much good, where we improved the accuracy for card trapper and face mask a way better. We got around 99%, and card skimmer is around 94%. So the final models which we used in our application are presented here. So for card skimmer, we are using from multimodal experiment, and hammer from multimodal experiment, and iron rod from multimodal experiment, and card trapper, it's from multimodal improvement experiment, and even the face mask. So these are the models which we considered in our final application. So this is the entire tabular column of each experiment accuracies. So you can see about the card skimmer, card trapper, hammer, iron rod, and face mask. So here is the final models of false positive rates. So even we figured out the false positive rates for each models we developed. And for card skimmer, it's around 3%, and card trapper is around 17%. And it goes on like that. We maintained a very low false positive rates for the models which we developed. So here is a short demo of our application, how it works. Please watch it.
Assume this as an ATM machine with inbuilt cameras, and this is the surveillance team monitoring the suspicious activities detected by our product. Now when a criminal comes to the ATM with a card skimmer, our product detects it, and the team decides to inform the bank. So an email is sent to the respective bank. Now when the criminal comes with a card trapper, our product detects it, and the team turns off the ATM. When a hammer is encountered, the detection of hammer is populated on the screen, and the team now clicks on the ignore button. Here the criminal comes with a face mask on, holding a card skimmer. Skimmer is populated on the screen, and a warning to remove the face mask is given twice.
Please remove the face mask.
If not followed,
If not
then the
followed,
mask
then it will
detection
be
is
reported.
populated on the screen. When the team clicks on police button, the local police service gets a call informing the suspicious activity.
Thank you for watching the demo. So here is the things we figured out in this paper. Multimodal approach provided many benefits over a single model for this application, as we proved the accuracies were around 99% for two of the classes, and around 94% for card skimmer, which is a pretty good reasonable amount. And the multimodal approach can be very accurate and be able to detect objects with 99% accuracy, as I said. And very little data was required to train for single class models. You don't need huge data sets, which we did in experiment one, where we used 11,000 images, just 1,000 images of the object, and 200 images of neutral images. That is enough to train a model, where we got a very good accuracy and with low false positive rate too. The data set should be diverse, consisting of various lightnings and times, different cameras, genders, and all these to achieve very good results. We do not require combination of objects in an image in the data set, which we differentiated between the experiment 1 and experiment 2. So there's only approximately 2% difference between 200 training samples and 2000 training samples. As you can see, in this curve, like you got like a very good accuracy with 200 sample images itself, and you can find the similar results with other models too. And we can improve the system robustness by integrating additional single class models as needed. So it is very simple to develop a new threat specific classification models. For example, if new threats are emerging with this issue, then you can immediately develop such models and integrate with our application seamlessly. So the future work of this paper might be something like to deploy the system in various locations to validate the model performance in real world scenarios. Like you can put these applications in like a different kind of situations and develop the additional single class models for emerging threats and neutral objects as they are identified. As I said, like you can develop the single class models immediately, like thinking about the new threats and then integrate with the existing system. And the another idea might be like automating the field data collection to enhance the model refinement and adaptation to new threats, like collecting the data automatically instead of manual human collection. You can make something like real time collection with like fixing cameras and then cleaning the data and then training the model and seamlessly integrating those models with this application, and then continuous improvement through gathering more data to refine the models for enhanced threat identification, as I said in previous statement. Then we highlighted the potential application of the multimodal approach and newer YOLO algorithms in diverse fields like beyond ATM theft. As I said previously, you can use it in public safety, retail, and manufacturing sectors too. So the conclusion of our paper is like innovative solution for rapid and accurate detection of suspicious activities or object. We proved that, and our solution can be deployed not only at ATMs but even also at like gas stations, vending machines, kiosk, etc. So we demonstrated a successful way of like providing high accuracies using a multimodal approach with the YOLO detection algorithm, and the seamless integration into like existing security camera feeds, offering a cost effective improvement to current infrastructure. Like you don't need to like fix a separate cameras for our application, just the existing cameras, it's enough to use our application, which provides a better accuracies and to maintain the low false positive rates. And the logs are generated by our application, and where the surveillance team can take appropriate actions. All this can be happening with our application. Yeah, thank you for your time.